Today we are going to talk about binary numbers. We're going to talk about what they are, how you can convert back and forth between binary and decimal. Now, before we begin talking about the conversions, just want to make sure that we're clear on the different types of numbering systems. The numbering systems that are out there, we have decimal, which is what we're accustomed to, binary, what the computers use, and these zeros and ones only. There's octal and there's also hexadecimal. So for in this PowerPoint, we're only going to be focusing on these two, the decimal and the binary. But here are some examples of what the numbering systems look like. You can see that this is 14. There's the binary. There's an example of octal, an example of hexadecimal. Okay, we're going to skip to this slide here. Now, when we're looking at binary numbers, we need to make sure that we differentiate between the least significant bit and the most significant bit, okay? The least significant bit is the number that's on the far right, okay? So that in this case, that number is the 0, okay? The most significant bit is the one that's on the far left, and in this case, that's the 1, okay? So we need to make sure that we know the difference between the least significant bit and the most significant. Okay, the best way to understand how the binary numbering system works is to compare it with the decimal system, and we can kind of look at counting. So here you'll see that I have a slide that goes through some counting numbers. You can see that it goes from 0 to 20 in decimal, and you can see that this is what the equivalent is in binary. Now there is a pattern here. If you look at the numbers, you start at 0, then we go to 1. Now, those are the only two numbers that are used. Now, since that, once we hit the maximum number of values in that least significant bit place, then we move over to the left. So now it becomes 1, 0. Now the 0 becomes 1, and since we've reached a maximum of 1 and 1, we go to the next place, 1, 0, 0. Then we go 101, and this 1 moves over to the left, and so on. Okay, so you can see the pattern that develops. Once the all the digits are filled with 1s, then we move over to the next place, and then all the numbers behind it become 0, and we keep moving forward. Okay, and this is the explanation of that in words. Okay, so you can read that when you have time. Okay, now to actually do the decimal to binary conversion, what we need to do is we just need to start to divide the number by 2, okay, and then we write the remainder down next to it. We divide the quotient by 2, write the remainder down, and we continue until we get to a decimal digit of 1, and 1 divided by 2 must be 0 with a remainder of 1. Okay, you're going to be working from the least significant bit to the most significant bit. So here's an example. If we take a look at this, we're using 22 as our example. Okay, 22 divided by 2 is 11. There's no remainder, so that's 0, and that's the least significant bit. We carry that number down to the next row. 11 divided by 2 is 5, but we have a remainder of 1, so we'll write that here. We'll carry this 5 down to the next row, so you can see that the quotient is carried down to the next row. 5 divided by 2 is 2, with a remainder of 1. We take the 2 down to the next row. 2 divided by 2 is 1, with no remainder, so we put a 0 there. And then we take 1 divided by 2, 0, and then we have 1. So if we go ahead and read these numbers, we're going to start at the bottom and work our way up, because we started with the least significant bit, and we go down to the most significant bit. So 22 decimal is equal to 10110 in binary. Okay? So that's how we convert from decimal to binary. Now going in the opposite direction, we have to be familiar with position weights before this conversion can occur. So we need to make a chart. So we write down the binary number at the top, and then starting with the least significant bit, we start with the number 1, and then we double that, then we double that, we double that. So we keep doubling. Or if you take a look, we've got 2 to the 0 power, 2 to the 1 power, 2 to the 2 power, 2 to the 3 power, 2 to the 4 power, and so on. So we write those across, okay? And what we need to do here, once we have this all filled in, okay, what we're going to do is we're going to add the numbers where the 1 appears. So it would be 128. In this case, it would be 128 plus 16 plus 8 plus 4. And that, in this case, ends up with a total of 156, okay? So we just need to make sure that we write the binary number at the top, and then we start from the right and go to the left. 2 to the 0 power, 2 to the 1 power, 2 to the 2 power, 2 to the 3 power, and so on until we fill in all our numbers below, okay? And this is a typed up version or typed up explanation of what we just went over. Okay. Here's another example here. So we're going to convert 0,11101 to decimal value. And I go ahead and write that in the top row. Now, if you like, you can eliminate the ones with the 0 in it. But I like to write it down. That way I know I've accounted for it. That way I know I don't just jump from 1 to 2. You can't do that. You would get the incorrect number. So I know there would be, in fact, a 2 here, and there would be a 32 here. But I'm only going to add the numbers that have the 1 above it, okay? So in this case, I've got 16 plus 8 plus 4 plus 1, and we end up with a 29. Okay, so that covers both sets of conversions. So what I'd like you to do now is to open up the practice problems and try doing the practice conversions on your own. The answers are also displayed in the practice.